Hey everyone. So I recently got a comment under my last video that asks, can you make a video about CRUD, BLoC, and some fetching data from API in Flutter? And I thought this was a really interesting request, and that's exactly what we're going to be looking at today. But before we even get into the code, I just want to take a step back, stop for a second and look architecturally at what we're going to build and kind of have a bit of an understanding of what we're going to build before we get to the implementation stage. Okay guys, so let's see how we can best design this application first of all. So I'm assuming that we will be creating some sort of to-do application, and to design this I want to use the repository pattern. So this pattern implies that there is a repository at the bottom of it, and this is none other than a class that actually executes the interaction with the database or our backend. So this class will include methods such as get to do, delete to do, create to do, update to do, etc., etc. And having these sort of methods contained by the repository has a great advantage on the application, because it keeps the application agnostic of what kind of data we are writing or reading, and it allows for greater separation of concerns, which means the separation between the UI and the business logic layer. And it also makes it really easy to swap the data layer if we wanted to in future, because all of the data specific logic is contained within the repository. So let's continue with our design. Here I will have my to-do block, and then on top of the to-do block I will have my UI. Now I'm going to go in the specifics of the interaction between the block, the UI, and the repository. So if you haven't seen it yet, please go to my channel and take a look at the basic block video that I made, because I think that's going to be fundamental to understanding the next steps. So now let's say that I am designing how to create a to-do. Okay, so my UI will have a component that the user can interact with in order to create the to-do. Once the component is interacted with, this will dispatch a create to-do block event. Again, I suggest that you go take a look at the other video if you want to learn more about what this means. Once the event is dispatched, this will trigger a function inside the block. And this function will execute some logic to create our to-do. In our context, what this function will do is it will create a DTO, or data transfer object. And this is an object that essentially will represent the to-do that we want to create. This object will then get passed into the create to-do within the repository. And then the repository will communicate with our backend, and it will go ahead and create our to-do. So once the to-do has been created, the backend will get in touch with our repository again, and the repository will create a to-do DTO, which will then be passed back into the block. Now at this point, the block will emit a new to-do state. That now, after this whole process has completed, will include the new to-do that we have created via the backend and that we've returned to our block via a repository. Now the to-do state will have our new to-do, and it will update the UI because the UI is listening to changes in to-do state. Now this might seem a little bit complicated, especially if you're just beginning with Flutter development, but I can assure you that it gets a bit easier when we get to seeing it in code. And also this promotes so many good principles in coding. Obviously it abstracts the data access code completely. So like we said before, all of the data related logic is included in the repository. It promotes reusability. It helps with unit testing. It makes unit testing much easier, and it makes it flexible to swap out our data source later on. Okay guys, so I decided to take a little bit of time to just model the UI for this example app that we're going to use in this video. So I've created a very simple to-do app, and I'm going to demo it for you first of all. So there is a list view with my to-dos here on the right hand side, and then there's this beautiful title, and then we've got a button down here, and all this button does is it opens a dialog where you can type in the name of your to-dos, and when you tap confirm, that will add our to-do to the database. So I've actually made some more changes, which, yes, they have just loaded onto the screen. So I've also added a edit button, which will bring up the same to-do dialog as this, but when you confirm, it will actually update my to-do. And then the delete button will obviously delete our to-do entry. So let's take a look at what happened on the code level. So as you can see, I've cleaned up the main.dart file, and as the home, I have used this new home screen widget that I created. So just for UI modeling, I created this dummy array of to-dos. And that probably leads me to the first point that I want to make. I created a class, which is, if we go back to our blueprint, this is our DTO, the model that will facilitate the conversation between our block and our repository. And then, so I have created this DTO here, and I called it to-do. I put it into its own file within the models folder. And with the help of my to-do class, I created this array here in the home screen file. And then let's take a look. We've got a scaffold, which obviously is the base of our widget, to which I've added a floating action button, which is my button here. And on pressed, this floating action button will show our add to-do dialog. Then if we go back to the widget declaration, here we've got a container, which is the wrapper around these widgets. And then as the first widget, we've got our title. Then we've got a little bit of space, and then we map through our to-dos array. And for each of those to-dos, we render a container, which is this box here. This could probably be its own widget, which I'll have to refactor later on. And we define some visual properties here to render the box in this exact way. And then we render those buttons on the box. So that's pretty much it. It's got some really basic functionality. There's another widget that I created, which is within the widget folder, and that's the add to do dialog. This is a very simple dialog. As you saw, this only has a text field at the very center, and then we've got a button to confirm, which closes the dialog, navigator.pop. And then it also calls, be great if I called this function properly. So it calls this function, which is a callback, and it passes in the text property of our text editing controller, which corresponds to the text that the user will enter in this text box. This can then be used back in our home screen widget. Whenever the onToDo added is invoked, we get the name, which is the name of our to-do, and then here we can do something with it, which we'll find out very soon what that is. On a slightly different note, I've also set up a really small Node.js backend using Prisma and Express. I'm not going to go into too much detail as to how this works, and this is completely out of the scope of this video, but if you'd like to know more about backend development, I'd love to do some videos about it, so just let me know in the comments below. And so here we have a post endpoint, which will allow us to create a to-do and save it to the database, a put endpoint, so this will allow us to update our to-do, get will return all of the to-dos that we've created so far, and delete will delete a to-do by ID. So let me open up Postman and show you how this works. So if I get all to-dos right now, I'll have an empty array. If I create a new to-do called my to-do, that will return my new to-do, and if I get all to-dos again, that will include the new to-do that we've just created. Then if I update my to-do and change the name to my to-do edited, I'll see that change. And if I delete my to-do, I will see it disappear. So I can verify that by calling get all to-dos, and that's an empty array again. So this is what we have to work with right now. Great, so how do we turn this into a fully reactive application that interacts with our backend following the blueprint that we created at the start of this video? Here it is again. So we've got our backend. The first thing that we need to create is our repository. So let's do that now. So I will go ahead and create a new folder, probably within the home feature, and I'll call it repositories. And then in here, I'll create my repository class. Now, in this class, I want to create 4 methods which will correspond to the CRUD operations: create, retrieve, update, and delete. So I've got all my methods now. As you can see, the compiler is screaming, but we don't really care about that now because we'll fill these out in a minute. But we have a create to do method, which will take in a string name, and this will create our to do. We've got an update to do method, which will actually require an ID as well as a name so that we can update an existing to do. Then we've got a delete to do method, which will delete a to do based on an ID. And then we've got a method to get all to dos, which will return a list of to dos. Great, so let's fill these out now. Okay, so I've created a simple HTTP service here as well. So this is simply a class that can be used throughout all of the repositories within the project. We only have one in this particular project, but imagine if you create more repositories, you'd want a single central service that connects with the backend and performs HTTP requests. So this is what this exact service does, and it has a single function. So let's actually go through it. So it has a client, late client, which gets initialized with the constructor of the class. And then it has a single function request, which takes in an enum value method, request method. This can be get, post, put, delete to cover all of the CRUD operations. And then it takes in a URL, which then gets passed into a URI. And then it takes an optional map string dynamic, which is the body of our request. And this will be used for our post and put requests. So what it does, it initially declares this response variable, and then it checks what our method is, and based on what it is, it assigns a different value to our response by calling different HTTP methods and also passing in the body where required. And finally, at the end, if the response status code is over 400, that's a problem, so we throw an exception. Otherwise, if it's below 200, then we just return a JSON version of the response.body. So our request function will have a return type of map string dynamic, or future map string dynamic. So now we're ready to be able to use this HTTP service within our to-do repository. So I'm gonna include it here. Great. Cool, so I've added my HTTP service to the to-do repository, and the last thing that I have to do is specify a base URL for our backend. So that's my URL, and we can finally get to filling out our methods here. So my create to do method will call HTTP service.request, and I'll pass in the request method dot post with my base URL. So my URL for the tasks will be my base URL /task, and then we also have a body for this, which will be JSON encode an object with the name. So that will be my response. And I actually forgot that within the request method, I have to JSON encode the body before sending it with the client. So I'll do that. I've done that now. Let me just fix the interpolation there. So that is my request, and if everything goes wrong, this will return a map of type string dynamic. Then once I've got my response, I can turn it into my to-do. So one thing that I like to do in my to-do, sorry for the pun, is I like to declare a from JSON and a to JSON method. And there is a lot of different ways to simplify this. There is an amazing library called JSON Serializable, and I definitely recommend checking it out. But for this example, we're going to write the two functions manually because it will just make it a little bit easier. Great, so here are my two functions. So the first one takes in a map of string dynamic, which is our JSON, and it returns a new instance of the class itself, the to-do class, with parameters taken directly from the JSON, as you can see here. And the second function, to JSON, returns a map representation of our class. And I like to have these functions within the class itself, again, to increase the separation of concerns as much as possible. Back in our repository now, we can return our to-do by doing to-do from JSON and then passing in our response. Great. Let's now fill out the update to-do method. So I'll copy and paste that code, but I will change my method to put. And I will also add my ID, append it to the end of the URL. Here we have it. And then for our delete method, I will do something similar there. Use the delete method and then remove the body in this instance because we will not need it. Again, I need the ID for the delete function, so I'll leave that one there. And then to get my to-dos, I will simply call base URL /task, and then here the method is get. My JSON in this case will actually be a list of maps. So I need to change this slightly. So I will do return response as list.map. And then for each JSON to do, I will do to do dot from JSON to do to list. And this should do the trick. Great stuff. So we have a repository and we can now communicate with our backend and create, update, delete, and get all of our to-dos. So let's go back to our blueprint that we created at the beginning of the video for a minute. And we can see that above the repository, we have the DTO. So let's say check, check, and check. And then the next step up is our block. So we need our block to communicate to the UI what changes have happened in the repository and the backend. I've already gone ahead and installed the 3 packages that we will require for this, which are BLoC, Flutter BLoC, and Equatable. And I'm now going to go ahead and create the files that we need. So I'll create a folder called BLoC within my home feature. I don't know if you can hear the wind, but it's really, really loud out there. And there is actually a storm in the UK right now. So apologies for the background noise. But let's create my to-do block and my to-do event and my to-do state. Right, let's start from the state. So I've just created my block state, which extends Equatable. And again, if you want to go through some of the basics of BLoC and how it works and how events and blocks and state tie together, I'd recommend going to see the basic BLoC tutorial that I've got in my channel. But in my state, I will need a list of to-dos. And I'm going to initialize that as an empty array. And then I need to create my copy with function. Cool. So that's my block state done. And then I'm going to create my block events. Sorted out my directive, and then let's create the abstract event. Give it a constructor, and then let's create all of our events. One to get all of our to-dos. one to add a to-do, which will also take in a name. One to update a to-do, which will both take in a name and an ID. And then one to delete a to-do, which will only take in an ID. Good stuff. So we've got all the events in place now, and we can go ahead and create our BLoC class. So todo BLoC extends BLoC. And let's write our constructor. Initialize the to-do state, and then cool. So I've got all my handlers up here, and I'm going to go ahead and create these methods now. Great stuff. So I've got my methods created, and now we just need to fill them out. So remember how we created a repository some moments ago? Now I want to use that repository within my BLoC. So I'll add it as a final parameter of the class and add it to the constructor. And then I can use that repository within my methods here. So remember how in our repository, there is a possibility that the methods throw an error. So if we go back to the HTTP service.request, whenever an error is caught, it gets rethrown. That then goes up to the repository level where there is an error handling. So we'll need to handle our error within the to-do BLoC. So I will wrap my repository method calls within a try catch statement. And when the error is caught, I will debug print that there was an issue. I recommend setting up some sort of logging service, but just for the sake of this video, I'll use debug print. And then finally, we can use our repository to perform our HTTP calls. And finally, we can use our repository to perform our CRUD operations. So let's do that now. So I'll do in get to-dos. My result will be await repository.get all to-dos. And then I'll emit a state copy with my to-dos. And then I'll emit a state copied with my result as the to-dos. Similar thing for adding my to-do. I will do final result is repository.add to-do or create to-do. And then I'll take my name from, don't forget the add to-do event had a final parameter string name, so we can then use that within the BLoC and inject that name into the create to do function. So event.name, and then we can emit state.copy with to-dos state.todos. So the to-dos that are already in the state plus my new to-do that has been returned by the repository right here. Then we have our update to do. Now careful to what I did here. So I updated my to-do, which gets returned in the result here. And then I went ahead and found the index of the old to-do within the state.todos, so the to-dos array in my state, by mapping the to-dos and taking just the ID and then finding the index of the ID of the to-do that I have just updated. Then I created a new instance of the to-dos in the state, the array. And then within that array, I swapped out the to-do at the relevant index for our result, so the updated to-do. And then I emitted the state with the new list of to-dos as the to-dos array. And then finally for the delete to-do method. And finally here, I didn't really care to bring back what the repository returns in a result variable like I did in the previous methods, but I still wanted to get the index of the to-do that we wanted to delete. And then once it has been deleted by the repository, I will create a new instance of the array, remove the to-do at the relevant index, aka the to-do that the repository has just deleted, and then emit the state with that new list of to-dos. Great, so our block is done now, and the last thing we need to do is connect our block with the UI, which should be very straightforward. So let's go to our home screen and let's first of all delete this list of to-dos. We don't need it at the moment. Now let's rename our screen to home view, and let's create a new stateless widget, home screen. What I'm going to do here is I'm going to wrap this with a block provider, create our to-do block, and pass in a new instance of our to-do repository, and then replace this container with our home view. So what this does is it places a instance of our to-do block above our home view in the widget tree, and it will let us use parent widgets like block builder in the child widget. So let's go and do just that. Let's use a block builder on top of the scaffold. And you'll notice I've deleted the to-dos array that we had created to model the UI. We can now replace this with to-do state dot to-dos, which is the array that we've been manipulating in the block. And now we can actually fill out the content of these methods here. So we've got a method to delete a to-do. So I'll do context.read to-do block.add. And here I'll add my delete to-do event and pass in my t.id. And notice that t is the to-do variable that gets passed from the map method over here. And then we've got a edit button, and to which I'm actually going to say, let's open the dialog, the add to do dialog, which is this dialog over here. So show add to do dialog, and I'll actually pass in a variable that I created earlier called update. And I will actually pass in a updated to do ID variable, or parameter, which I added to this method to indicate that we are actually updating a to do and we're not creating a new one. So t.id again. Okay. And then the last method that needs to be edited is the callback for my show dialog, which we looked at the beginning, near the beginning of the video. And here I'll want to do if updated to do ID is null, then I'm going to return context.read to do block.add create to do or add to do, and then I'll pass in the name, which I've got already as a callback from my method here. But if not, I want to update my to-do, so I'll do update to do, and I will pass in my ID here as well. And I can actually simplify this by saying final block is this. Great stuff. I noticed that I actually created a delete to do function here, but since I've already declared this over here, I don't really need this. And the last thing that I want to do is when I get to the home view, I want to load all the to-dos. So I'm actually going to change this to a stateful widget. And then using the init state method, I will dispatch a BLoC event. Get to-dos. Now the last thing I need to do that I forgot to do in my BLoC state is to actually add my to-dos array in the props list that we override from Equatable. And this will actually make sure that the UI is able to differentiate between versions of the to-do state that have different to-do arrays. So let's do that. And that's all there is to our application. So fingers crossed, moment of truth. Let's reload the app. And let's see. So just a couple of pointers after seeing my application restart and miserably fail. So first of all, I had to add a new entry in debug profile.entitlements to allow my macOS application to be a client that can connect to the internet, which is not the case by default. And I tend to keep forgetting about this every time I create a new app. So make sure you do that. And there is also an equivalent version for iOS and Android, if I'm not wrong. So make sure you check that out. And then in my HTTP service, I actually had to pass in a content type header, in this case application.json, which is the type of message that we're sending in the body. And the last rookie mistake I made is that I actually called the root task for some reason, but it's obviously to do. So after restarting the application now, we can see that there are no to-dos on the screen, which is kind of the expected behavior because we haven't created any to-dos yet. But when I click on plus and type in my to-do and confirm, I'll see my to-do appear. I can edit this by saying my to-do modified. There's a lot of room for improvement here. The text field could load the name of the to-do as it is now, but it obviously doesn't do that yet. And as you can see, when I edit the title, it changes in the list, which is beautiful. And then when I close, and then when I delete my to-do, it goes away from the list. And if I reload, my to-do isn't there anymore. So yeah, guys, these are really the fundamentals of creating an app that can interact with a backend using HTTP requests, with Flutter using the BLoC architecture, but also the repository design pattern, which I think is a very solid pattern that every developer should be aware of. If you like this video, if you think this video brought you some value, please consider subscribing to the channel and hit the notification bell if you want to stay updated with my new videos around Flutter, mobile and full stack development. If you have any requests for any new videos, anything you want to learn in particular, feel free to leave those down in the comments below, and I'll see you in the next video. Cheers.